Coming back at you with another interview question. And this one, we're going to talk about a problem in Verilog where you would like if a module can tell you if a number that you're streaming in is divisible by n. If you recall, I go here. We did this finite state machine problem in an earlier video where basically, all right, so every cycle a number is left shifted by 1 and a new bit is injected in this LSB. And this bit injected is going to be made by this bitstream signal. And so what you want to do is you want to calculate if this number that's kind of being left shifted every cycle is going to be divisible by 5. Now, let's maybe make it a little bit more interesting and yeah, let's make it divisible by n instead. So, hold on to your hats because this is going to be perhaps a longer one because it's a little bit more, it may be a little bit more complex. Who knows? I don't know. But the whole theory behind this problem is, instead of modulo 5, you might want to do modulo n. If an interviewer asks you like, hey, I want to see if this number is divisible by 13, in the allotted time, there's no way you're going to write, I mean, you can write, 13 states in the allotted time, but it's just like a lot of menial programming. And it's, if I'm asking 13 states as opposed to like 3 states, as an interviewer, you can kind of deduce that they're trying to see if you have a better way of doing it other than the brute force way. And I'm going to talk a little bit slower because a few hours ago I ate a lot of carbs, so I'm a bit slower. Definitely not carb hitting, so I'm in the stand-up position on my stand-up desk. And also I recorded like an hour video already, so I'm like a little bit fatigued talking for an hour, even though I finished my protein shake. But yeah, so to reiterate on the problem, and also it's important to stay hydrated. Otherwise, in a very long, so not for a phone screen or anything like that, but for a like on-site interview, definitely ask for a lot of water, because then you get a lot of pee breaks, which is an excuse to move your body and get the blood flowing, but also hydration. It really helps with concentration and mental fatigue. I don't think protein powder in almond milk is, I mean, it's somewhat hydrating, but it's not really like as hydrating as water, I'd reckon. Also, I didn't drink that much liquid. It's mostly powder. But anyway, let's talk about the problem. Every cycle number is left shifted by 1, so, and then a new bit is injected in LSB. So basically, you want to know if this number is divisible by n, or basically, you're going to put that number that's being left shifted every single cycle in a framework of modulo n. Okay, and do I want any parameters? Like, if I have the parameter as like 13, right, then yeah, we could try using parameter. I'm not sure how to solve this problem. So input logic is gonna be what? Clock reset n, and then output logic is just gonna be divisible by n, and input logic is also going to be bitstream. I feel like if I'm asking this question as an interviewer, I'm not going to go ahead and also have them do this because it seems like it's complicated enough already. And if I have time, which I probably won't, at the end of this video, I might put an enable and then kind of show you how, like, just the grunt work of using, like, stopping this, whatever I'm going to implement, if enable is 0, right? So logic bitstream logic divis on n, and then let's just instantiate it. Sorry, mod is I7. I don't know why I like prime numbers so much. It's gonna be a little annoying to test for, but well, we'll see. Okay, so we have 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's good. Let's see if it goes ahead and compiles n to the O. Okay, definitely. Okay. So what's the plan here? So okay, if it's so how do we do it in our brains, right? If I give you a number, let's say 69, right, that you can almost instantly say that's modulo 4, but how? Well, you know 65 is divisible by 13 and you're minus 4, but I guess the good thing with this bit stream is that no number from one cycle to the next is going to be more than 2 times plus 1 the previous number. So theoretically, if you're operating on like a modulo 13, right, and you have like 12 mod 13, your worst case is going to be in the next cycle 25 mod 13, right? So you, in theory, you could have like some logic, of kind of just keeping track what module you are in. Oh man, I'm gonna definitely misspell this to module so many times. I can already predict what, like, I'm gonna make mistakes on this video. But basically, you can say, well, the worst case is 25, right? So it's just 26. So basically, like, if you have twice this number and you ceiling log it, you're pretty good. The exceptional case being like 1. So 1's C-log is kind of annoying because if you do C-log of 1, that's 0, and a lot of times you use the C-log, as some sort of a width, and then most of the time you do like logic with minus 1 is 0, so like 0 minus 1 is negative 1, 0, so that would throw an error. But for all cases where it's not 1, it'll work. So if an interviewer needs you to do this and it's a C-log situation, C-log 2, C-log base 2 situation, then you can tell the interviewer, well, either prohibit using 1 and have them agree to it, or you could just pad an extra bit so that even if it's like, modulo 1, actually, if it's a modulo 1, you can always just return true, like, if, you know, real answer, right? So you can do something like this if for this specific case, and then the parameter being 1 is a real problem. Like even like in other problems, like if you have a FIFO or anything like that, where the width can be very like the depth of the FIFO, so how many entries on the FIFO are going to be variable FIFO, you're going to run a lot of trouble if the parameter equals 1 if you're just using a naive ceiling of log 2 because of this thing. But yeah, I mean, in that case, you know, you might just write two pieces of program, like one for like cases 2 and above. And if the parameter is 1, then you just have a separate circuit that's just a flop because that's all it is. Like a FIFO, that's a single entry, it's just a set of flops. Yeah. Likewise, if the modulo is 1 here, it kind of converts to a useless module. So yeah, I'll start by not considering mod 1, and then I'll just do this later. Yeah. But the thing is, I don't want to do mod 1 up front because if I do mod 1 up front and I derive some C-log stuff, later on if I do like, yeah, like I might, it's kind of annoying to wrap my code around, you know, if-else statements before I need to do it. So, all right, so yeah, so a lot of intricacies here. But anyway, your worst case here is just gonna be basically like, you know, like if your local param is like max mod is like 13 left shift by 1, then you can have another local param where, so this is like 26 in this case. And yeah, this is 24, 25, yeah. 12 mod 13, yeah. And then, so what you can do here is you can say mod width is gonna be the C-log2 of mod. So if you have mod 2, so for example, if this number was a 2, this would be a 1. And if you need to represent you know, 2 numbers, then it's your width minus 1 colon 0. So here I'll show you, like for example, so if this was a 2, this would be a 1. 1 minus 1 is 0. A single bit can represent 2 states, so that's okay. And then if this is a 4, this would be a 2. 2 minus 1 is 1, 0. And then you go from 0 to 1, 1, 1. Yeah, 0 to, yeah. Sorry, not 1, 1. 0 to 1, 1, which is going to be 4 separate states. Now, if you are not comfortable with that, and you want to just pad an extra bit as an interviewer, and in real life, I don't care if you add an extra bit, to be honest, because it's much better to not have buggy code that's imprecise than have very precise and buggy code. Because at the end of the day, like, you do your job, right? And what's the whole point of the job? You want to make the minimal effort so you can just take your money and go home, right? So, you know, the more anal you are about these like kind of bit stuff, the more you're just kind of wasting your life, frankly. So, yeah, yeah. In this case, it's kind of more calculate as an example to show you, but in a real life scenario, like if you throw away, like if you have 1 extra bit for just to be safe, like like no one's gonna care at all. Anyway, rant over. So I'll just call this mod space as in modulo space. And if I'm streaming a bit in, I want to say um, So yeah. So maybe I just want to see what the simplest way. I can just do it like this, I guess. So if I'm not in reset and it's a bitstream, so it's like, you know, then mod space is just gonna be the mod space times 2 plus 1, and maybe like this. Otherwise, this is just a times 2. Yeah. So yeah. So yeah. So yeah. So let's do this. Ready for this parenthesis. So one thing I'm thinking about is like, how do I subtract back out this modulo number? So I guess at the beginning of the cycle, I need to know if the number is more than the modulo. If it's more than modulo, I subtract it. So let's see. This is the space of the modulo. I'm just trying to think what to call this number. If it's greater equal to mob, the modulo, so let's say it's modulo 13, but then, you know, I flop this and this is like 14, then you would just want to do like mod space minus mod. And then so once you're done with that subtraction, and then once you're done that subtraction, then, you know, whatever bitstream is that's coming in this cycle, you can then process that, not space club, space sub. You can just, so for example, let's say you have 14 this cycle from, so let's say you have like 7, and then 7, you stream in 0, you have 14, 14's more than 13, yeah, so like you get 1, and 1 here, and then, but then, you know, it was bitstream 0 from 7 to 14 the previous cycle, but maybe the next cycle bitstream is 1, right? So in this next cycle where bitstream is 1, you do your 14 minus 13, so it's 1. And then you go here, so it's 1 times 2 plus 1 is 3. And next cycle it's like 3, and then you do this check again here, like 3, is this more? No, this is not more than the modulo, so you just keep this. And then so what you'll end up with is every time you have a bit stream coming in, the next cycle, you can see if it's divisible by n, just purely just looking at to see if this is 0. And if your interviewer wants you to do something where, like, I want to know in this exact cycle, then yeah, I mean, you can just do the right hand side instead, as opposed to the left hand side. Yeah, because it's the same data, right? You're just flopping the same piece of data. Like this doesn't do anything; it's just flopping it. So if you want it one cycle earlier, you do right hand side. But in this particular case, it's a little bit complicated already. So I'm just gonna go easy on this one and say left hand side, because I'm sure there are a ton of bugs, and I doubt this compiles. So, well, okay, well, look at you. Okay, well, whatever. All right, so I guess I'll just start testing it out. Yeah. So clock is 0, reset is 1. And the thing is, how did I do it last time? I had like a test vector. And the test vector I was streaming bits. Okay. And I think I like a display vector just so I can kind of see what's going on. And then I'll probably just do like a task print and clock begin end task, and then I'll just like display in the next cycle as opposed to this cycle the display vector D. I'll just cross-check with Google what the modulo 7 is, for example, and then I'll do probably do bitstream first, and then I'll do divisible by n, which is my answer. And then what I want to do, is there anything here that I care about the mod space? Yeah, probably the mod space. Since I'm doing after the clock, it's a lot simpler just to look at this. I don't know. Anything else? So this would be a D. And then I'll just do bitstream display vector, and then I'll do like divisible by n. And I'll do I mod n dot mod space, something like this, and then bitstream, let's say, is 0, and then test vector is 32h dead beef, and then I'll play with the display vector later. Right now, I'll just say 0. And I believe that's it. Let's run. The Divisible by N hasn't been declared yet. So that's like another thing. Misspellings in an interview is extremely harmful, while you never ever misspell anything in a real work environment because there's this thing called autocomplete. So, how do I want to do this? So, let's print and clock, and then let's set reset 0, and then I'll just run this once, and I'll do a for loop to test. Okay. Okay, that's great. So yeah, I guess dead beef doesn't really mean much to me. So whether it's opposite or not, I really just care about this display vector. So I might initialize this. Yeah, I might actually just initialize it here, and I'll just say for int I equals 0. And I'll do like bitstream. So normally I would do like the opposite and then just like run through left to right. But in this case, I'll just do right through left. Because I really just care about this display vector, which this display vector, when I shove in the LSB, is the view that this module and module will take anyway. So yeah. So I stream this in and I just print and clock, and then let's see what we run into here. Actually, is there anything else I need? My resets to 0, that's great. My bitstream's changing each cycle. And then my yeah. What? So I don't get how mod space is 7. So this should be 1, right, by any account. So it's important not to panic when you need to debug, because debugging is quite normal. So my mod space is 7, but divisible by n. So I go from 0, 1, 3, 7. Okay, that's simple enough. So I go from 3, and I stream a 1 in. So it's a 7. And so one cycle after, my mod space is 7. So if my mod space is 7, this subtraction will take care of it, meaning 7 minus 7 is 0, but I'm actually hooking into this one right here. So I could there's two solutions. So I can do this, and then or this. Or I could just keep it simple, but might run into timing issues. Just depends on your interviewer, but both are valid solutions. Just take this as 0, and let's see if that works. Okay, so I just kind of want to scan, like there's no obvious like is 247? No. So this is so far so good. This is so far so good. So far so good. So far so good. And then this mod space 5. Yeah, because 63 would be mod space 7. I stream another 1 in, so then 5 times 2 plus 1 is 11. So this is where it goes wrong. So if I'm a 5 times 2 plus 1 is 11. Eleven minus 7 should be 4, right? Not 3. Yeah, wonder what's wrong here. This is also going to be quite a long stream. Let's see. Yeah, it's 4, not 3. I wish I could like print. So mod space was 5. And so 61, put a 1 in here. 61, which is 5. So if I do like 61, I believe that's still correct. Okay. So 5 times, what if I did this? What's the log 2 of 7? 2.8, so it's like 3. So 2, 0 won't hold 11. Oh. Okay. So this would work. But you see what I'm saying? Like, if I had just been conservative and not done -1, it would have caught for this issue. Where I was missing a bit on top of here. This should be max mod because in the earlier explanation, right, the worst case is 2 times of this, but I was C-log2 of the original as opposed to the max mod. So max mod wasn't, I created this variable, but I never even consumed it. Okay, so let's just check, right? So 0 and 7 is cool. Is this divisible by 7? Please. Yes. Great. All right, I guess this is also divisible by 7. This is how you know when the code works, right? When you yourself don't really know the answer. Let's maybe try to check a little bit more. Let's just say 3. on the same thing. And so, right. Right. So maybe this is, you know, no, that's good. This is, no, okay, yep, 9, 21, 3, that's okay. This is 4, 5, 12, and 17, yep. And I think I did 18. 18 plus 15 is 33. 33 plus 6 is 39. And let's just check this one. I'm just gonna not do mental math. All right, cool. Cool. The trick I was using, I was just summing up the numbers, and if the sum of the digits is a multiple of 3, then it's divisible by 3. So, and vice versa. It's kind of if and only thing. So, yeah, I mean, that's it, you know. I hope you enjoyed. I'm going to take a snack break because it's Saturday, aka cheat day, aka Saturday. Let me know in the comments what I should eat, but it'll probably be too late. But I'll save it for next time. Should it be A, Italian biscotti that I got from Italian? Or should it be B, I should just drink another protein shake and stay healthy? Or C, um, what do you mean you're trying to take a snack break? You need to make another video because that's all you're good for, aka you're my manager and you stumbled upon my video and you somehow want me to have even more output. Yeah, in that case, um, yeah, let me know in the comments. And yeah, with that depressing note, I'll see you next time.